Hello everybody. Hello students. Happy National Science Day. 28th February we all celebrate. Uh, the purpose of coming to this video on YouTube is the following. I'm not going to discuss today about Raman effect or anything like this. But you can have plenty of people, experts, explaining that particular thing and explain the certain topics. I'm here to start something slightly different. And I'm quietly doing it, not declaring it that I will do big things starting today. But we will grow it. We'll grow it together. What it is that I've been teaching in UM-DAE Center for Excellence in Basic Sciences inside the Mumbai University for last 11 years. And then I taught in IISER Berhampur as well. And finally, I started teaching basic astronomy through my Facebook and collaboratively with different research institutes to the collaboratory called Astronomy Collaboratory. It has been 10 years since I started involving undergraduate students in research through Reddit. Probably I'm realizing that when I'm doing it through social media, Facebook, maybe 1/3 of the undergraduate population is only getting involved in the process of touch. 2/3 remains outside. So after 10 years, I'm thinking of taking it to the all people who have access to internet through YouTube video. I'm not going to confine it. That is what is my current plan. I will invite my collaborators, astronomy collaborators, some very good outreach scientists, and different kind of activities, student discussion, everything into this kind of YouTube video broadcast. I'm not very sure that I will be doing it on every Thursday or every weekend, but we'll post small videos regularly once every week. That's what is my plan. So let's start some basic astronomy learning. It will not be very rigorous mathematical. It will not be showing the detailed data analysis that can lead to some research result. For that, you have to come and join the Astronomy Collaboratory. But let's start a small way that one way YouTube video like communications can also do something. Okay, I will start my screen share. Okay. So basically, what I'm sharing is now one can call it nationwide inter-university astronomy e-class, online class. So let's start with the slide. One day, 2 days back, on 25th morning, rather, I got up and went to a balcony to have a cup of coffee there. When I saw that something is bright on the edges of my balcony, it has to be moon. And I see more that it is difficult. I have to pop out, peep out, and see that this is a moon. Took a photo. In the other days, moon is mostly here, so one can see a proper view. But here is moon. So I immediately went and checked in my Stellarium software. You can download it in your mobile, you can download it in your Windows or Linux, whichever system you have. It's a very wonderful software. You must download. It's called Stellarium. Okay, so we'll have some screenshots from Stellarium also. So to check basically where is the moon. It will not show my building, but it will show the coordinate system in the sky according to my position in Harvard, by where I am, and the time, the IST time, 6:30 around that. I posted a discussion. We'll come to these points slowly. What I posted is this picture from Sri. What it shows? It shows the west direction. North is here, so this is northwest, southwest. So from north, if it is 0, 45 degree, this will be 90 degree on the horizon, azimuthal angle. So from the west, the moon is 10, 20, 30, 40, 45 degree away. It's northwest. So the moon is roughly like 5 or 7, 8 degree away. From the ground again, it's called altitude. So ground again, it is more than little 10 degree, more than 10, say 11 degree or something, 11, 20. So this is where moon is. So this is the rough coordinate in altitude azimuth system, I can tell you, where moon is in the sky. Now, with respect to the permanent background constellations, that doesn't change every minute, where it is. So I have selected the constellations line drawing as well as the picture that is we are supposed to imagine for these constellations. So one can see the tail of the Leo constellation and the Virgo or Singha and Kanya. So somewhere their moon is in that location. So if I remove this background, tree, grass, etc., the light, the atmospheric brightness, etc., I get the other picture that more stars are there, full constellation one can see. So moon is somewhere in this Leo constellation. I zoomed out a little bit, of course. So moon is somewhere in this Leo constellation, close to this bright star Regulus. Indian name for this regular is Mogha or Magha. I'm not quite sure which part of India how to pronounce it. So moon is in that location. Few hours back, it would have been here. One day before, it will be very close to this. So what we are trying to understand here, the constellation shape is not changing in few days or hours or months or years time. So one can have a description of where the moon is, permanent description. Okay, it is like one way to describe the position of the moon is changing every second. But where it is going, one can describe, but the permanent sky of the constellations drawing. So if we draw this kind of latitude, longitude, or RA depth in the sky, this called, if we fix them by the stars, then one can tell exactly where the moon is precisely to the few second accuracy. That is why people design this coordinate system, and the background sky is the permanent thing that we know. Every year, at this time, sun is supposed to come this position, the moon is supposed to come this position. One can predict. Okay, so this is the star that we are talking about, the brightest star in the Leo constellation, Regulus. The red dotted line is the path of the sun and moon when we go around the sun. This is basically the other way around of saying the sun moves through this path. So throughout the year, basically, the sun's position in the sky is changing. And we Indians have identified 27 nakshatras, 27 stars in its path. Moon is also taking 28 days to go around Earth. So every day, roughly, the moon move from one nakshatra to another nakshatra. Out of those 27 nakshatras in the sky, the moon is shifting one every day. Sun's path is also crossing this 27 nakshatra, but there are 12 months. So we picked up 12 nakshatras from those 27 nakshatras and named months accordingly. So the month name is according to the stars in the sky where the sun is. The month is nothing but time period of the moon. Okay, So coming back to the post now, what I have posted the previous day actually, it is Magha Purnima. That was the day Magha Purnima. Magha is the month name, Purnima is the full moon. Where is the moon, full moon today? Why it is named like this? Magha means plentiful of grains or something like that. Magha is the Indian name of a star in the sky. In this regular, it is a bright star in the constellations of Rasi, Leo, Simha. This month is nothing but moon time period to go around Earth. Is named Magha because it is located to the star Magha. We Indians name our months according to where the sun is in its path crossing many constellations. See the image from Stellarium and Wikipedia posted here. Note that the images are not for now. The images are for now, but it's exactly when I came to balcony and opened Stellarium. So a few days back, when it was exactly full moon, sorry, not few days, 1 day actually, previous day, it was exactly much closer to here. Okay, what is supposed to be passing through this dotted line, very close to that. I don't know if it will even occur. Okay, so the modern astronomy is not just the position and where the moon is, where the star is, where the position, how is the accuracy, what is the time, etc. That's a positional astronomy, Siddhantic astronomy. Modern astronomy started applying various measurements in multiple wavelengths, measuring the amount of light, measuring the spectral lines in that light from the star and the planet and the galaxies, etc. So coming to modern astronomy, looking at these stars again, modern astronomy has given us many interesting details about this bright star Magha. See, for example, a few lines from the Wikipedia, which I am quoting. The primary of Regulus A, the star Regulus, is actually a twin star or a binary star. The primary or the main bright component of that, Regulus A, had 3.8 times the mass of the sun. So sun's mass is suppose 1 unit, then this star is 3.8 times more massive. It is spinning extremely rapidly with a rotation period of only roughly 16 hours. For comparison, our sun takes 25 days to spin around its own axis. It's taking 16 hours. Imagine how fast it is rotating compared to sun. This fast rotation causes this star Magha to have slightly oblate shape. What is oblate shape? Oblate shape is like a sphere which is compressed from the bottom and top. This flattens. Something like Mumbai, Maharashtra. So if you put the vada into a pav, it kind of flattens a bit so it fits in easily. I am also originally from Odisha, western part, Manda. So some patterns of Manda are flattened so that it can be baked easily on the pan. Okay, that way, what is happening? Because of its fast rotation, the central equatorial part of the star is kind of bulging out, spreading outward. Because of the fast rotation. If it rotates slower, it will shrink because the gravity will pull it back. Because of this, the equatorial part of the central belly part of the rotating star is coming bulging out. So the light that is being generated at the center is being absorbed, scattered, etc. And probably something is happening like that. I'm not a stellar astronomer, I'm not an expert in that. That is why that part is less luminous, less bright compared to the pole region. This results, as I have written here, this results in so-called gravity darkening. The area, the photosphere at Regulus's pole is considerably hotter and 5 times brighter per unit surface area than its equatorial region. Equatorial is the Viswavruta or equator region like Earth. The pole is brighter and hotter. The star's surface at the equator rotates at about 320 km per second. There I told you there only the time period. Here the speed, orbital speed at the equator is 320 km per second. Imagine how fast this is. And this is 96.5% of its critical angular velocity for breakout. What do I mean by that? What does it mean? Suppose, for example, imagine how fast Earth is rotating. 24-hour and 60, fine. But now you put the circumference to the diameter and calculate what is the velocity on the surface of Earth at which we are going towards the sun in the morning and away from the sun in the evening. It's roughly like half a kilometer per second. We are moving on the surface of Earth at roughly like half a kilometer per second speed because of Earth's rotation. Whereas at the equator, the star's surface is rotating at around 320 km per second. If we move at 11 km per second, we will escape Earth. That is the escape velocity. Here, for comparison, it is more massive and not in Earth, but not in Sun, but 3.8 times more massive than the Sun. There, it is still able to hold it. The gravity is stronger to even hold the object that is going at 320 km per second speed. But it is very close to breaking 96.5%. If it crosses this 100% value, whatever it is for the star, the part that is, will not go around, it will break apart from the gravity of the star. And because of this kind of things, the plasma at the equator is also stretched, and that maybe, I don't know, the scattering is causing that, or the emitting plasma is behaving like that. The light that is emitted from the star is highly polarized because of the stretching, the bulging out. Now imagine, because of reflection, one can get polarized light. If you have a polythene sheet with the colored light, semi-transparent, you can see through that and stretch it just before breaking. All the polymer that is there in the polythene are now stretched, are aligned again. So when light passes through that, that also gives a selective transmission, that is also polarized. Polarized sunglasses are available. One should try in any shop. If you go, you can ask that. You see through it. Both are, one can pass through a lot of light. If you rotate it, they are cross. So they will not pass through. So that will become darkened. What you should experiment when you go to this kind of a chashma dukan goggles store is that see the light directly, see the reflected light. So the reflected light is polarized. So your polarizer will see that the light is getting blocked. Polarized light will be blocked. Very similarly, rainbow is also a total internal reflection that has happened, right? The rainbow is also a polarized light. Very interesting. So if you have the kind of polarizer, the rainbow light will not pass through because it is polarized. You rotate it, the polarizer again, it will pass through. Okay. So that way, note that we started from this position of the stars and planets in the sky, started looking at the detailed, interesting physics of the stars there, because the modern astronomy. If we have much bigger telescope or much longer exposure, we'll start seeing not just the stars and the planets, but the background galaxy. If you look much deeper, days with the Hubble Space Telescope kind of thing, then you will be able to see far, far away galaxies from which the light has taken billions of years to reach us. Or it will be indirectly telling how the universe was billions of years ago. We'll start understanding the universe. So, for today, this is where I will stop. And next week, within a week, I'll be discussing some other aspect, galaxies or stars or the positional astronomy, I do not know. Maybe we'll start talking about how to measure the moon from your mobile phone. It is not just a pretty picture that we should appreciate, but we should actually take a photograph. For example, this picture that I have posted. What is the size of the moon? Can I measure from this mobile picture? What velocity the moon is moving, going down? Can I measure? You all know that if I can stretch my finger this way, that I can block the moon and sun. So my finger is actually bigger than the moon and sun in angular size. What I'm talking now is that can we measure the angular size of moon with taking a photograph with your mobile phone? Taking a video, can we measure its angular velocity? What velocity it is moving? So we'll talk about few more and more details. It is not just to appreciate, we should start developing the habit of measuring or expressing things in number, expressing things in the analytical way. Or what I mean is that it is not to express only the wow part. It is also necessary to understand and analyze critically. That is what as a what you call as a species that has brain would be able to make most out of whatever is available to us. We have to protect ourselves. We have to evolve in a more secure or intelligent way. Okay. Thank you very much. See you next week. And if you subscribe to this channel, as everybody says, you will be getting notified. Okay. See you. Bye, everybody. Thanks. Bye. Happy Science Day.